Let us look at proposition number 62 of book 10 of Euclid's Elements. The proposition says the square on the second bimedial straight line applied to a rational straight line produces as breadth the third binomial. So here, let AB be a second bimedial straight line divided into its terms at C with AC greater than BC. We set out a rational straight line DE. Apply a parallelogram DEFG to DE equal to AB square. When we apply that, we get the breadth, that is DG. What the proposition is saying is that DG is going to be a third binomial straight line. So let's see how we can prove that DG is a third binomial straight line. Now apply a parallelogram DH equal to AC square to DE. Then apply a parallelogram KL equal to the square on BC to KH. Now here it says DE mainly because KH is equal to DE and we don't want it to be drawn here. We want to add it up. Okay, so DL is DH plus KL. DH is AC square and KL is BC square. So AC square plus BC square is DL. So that the remainder MF will be equal to 2 times AC by BC. Okay, now we bisect MG at N so that MO is equal to NF, each of them equal to AC by BC. So now, based on the definition of a second bimedial straight line, we know that AC and BC are medial straight lines commensurable in square only. AC square and BC square are medial. AC by BC is a medial. Now, since AC square and BC square is medial, that means AC square plus BC square, which is DL, is also medial. And this DL has been applied to a rational straight line DE, which means DM, base of DL, is rational and incommensurable with DE. Since AC by BC is medial, 2 times AC by BC will also be medial, which means MF is medial. So DL is medial, MF is medial. Now MF is applied to ML, which is equal to DE. So MG is rational and incommensurable in length with ML, which is again DE. So AC is incommensurable with BC and AC is to BC is equal to AC square is to AC by BC. AC measures AC square AC times and BC measures AC by BC AC times. So same number of times. We have AC square is incommensurable with AC by BC. Why? Because AC is incommensurable with BC. AC square plus BC square is incommensurable with 2 times AC by BC. Because here, remember, BC square is commensurable with AC by BC. But since AC square is incommensurable with AC by BC, AC square plus BC square is incommensurable with 2 times AC by BC. Now, AC square plus BC square is DL. 2 times AC by BC is MF, which means DL is incommensurable with MF. Since the areas DL is incommensurable with the area MF, that means there is, the bases will also be incommensurable. That is, DM is incommensurable with MG. So, DM and MG are also rational and they are incommensurable with each other. So, therefore, DG is binomial. So, now we have to show that it is the third binomial. AC by BC is the mean proportional between AC square and BC square. AC by BC is MO. AC square is DH. BC square is KL. So that means MO is the mean proportional between DH and KL. This can be written as a proportionality. DH is to MO equal to MO is to KL. Now DH is the area, MO is this area, and KL is this area. That means this proportionality also applies to the bases. dk is to mn as mn is to km. And this proportionality can be written as dk by km is equal to mn square. dh is commensurable with kl. Why? dh is commensurable with kl because AC square is commensurable with BC square and DH is AC square and KL is BC square. Okay, which means DK is also commensurable with KM. Now, based on the lemma, we can say AC square plus BC square is greater than 2 times AC by BC. AC square plus BC square is DL. 2 times AC by BC is MF. So DL is greater than MF, which implies that dm, which is the base of dl, is greater than mg, which is the base of mf. dk by km is equal to mn square. Now mn square is 1/4 of mg square, and based on this we can say that dk is commensurable with km. So we have shown that dm square is greater than mg square by the square on a straight line commensurable with dm, and dm and mg are incommensurable with de. Where did we show this? Here, if you notice, dm is incommensurable with mg and dm is incommensurable with de. So dm is incommensurable with de, dm is incommensurable with mg. So we can say dm and mg are incommensurable with de. That means dg is a third binomial straight line. So that was proposition number 62 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.